Okay, let me close this out. Where are we? We are on chapter 1. We are on chapter 1, section 7. Biotalk, the water cycle. Water is necessary to life in many ways. Land plants absorb water from the soil, and land animals drink water or obtain it from their food. Water constantly bathes organisms that live in ponds, lakes, rivers, and the oceans. Other organisms rely on water to carry nutrients to their cells and organs. The cytoplasm in cells is mainly water. Every day, about 1,200 kilometers squared. I'm sorry, you guys knew that. Every day, about 1,200 kilometers cubed, okay, you knew that, of water evaporates from the ocean, land, plants, and ice caps. An equal amount of precipitation falls back to the earth. That's kind of interesting. So, from everything that evaporates, an equal amount falls back. So the earth doesn't lose water, it just keeps evaporating and then raining down again. All right, where am I? Okay. The volume of water in the biosphere remains fairly constant through time. In fact, the water that you use today has been around for hundreds of millions of years. It has probably existed on the Earth's surface as a liquid, a solid, and a vapor. However, water is always moving from place to place. It is forever changing from one state to another. This complicated movement of the Earth's water is called, let me see if I can hide this. Hold on. Okay, there we go. Water is forever changing from one state to another. This complicated movement of Earth's water is called the water cycle or hydrologic cycle. Some of the pathways of this cycle are shown in the diagram above. All right, so let's look at this diagram of the water cycle. And here's the pond or the lake or the river. You have evaporation, condensation, precipitation, which also means rain or snow, and then it falls back. So it is a cycle. You have your groundwater, runoff from streets and sidewalks and things and rocks, and then going and then infiltrating and going into the groundwater, evaporation from the runoff. So it's a cycle. You know, you have different evaporation moving upward, and then you have your condensation and your precipitation moving downward. All right. One of the largest reserves of water on Earth is found in the oceans. The oceans contain about 97% of the Earth's water. Other surface water includes lakes, rivers, estuaries, marshes, and swamps. By contrast, the atmosphere holds less than 0.001 or 1/1000th of a percent of the Earth's water. This means that rapid recycling of water must take place between the Earth's surface and the atmosphere. By absorbing heat energy from the sun, some of the water on the Earth's surface changes to water vapor by evaporation. It rises upward into the atmosphere until it reaches a point where the temperatures are low enough for the water vapor to condense to form tiny droplets of liquid water. This process is called condensation. These droplets of water are light. They collect around dust particles, forming clouds or fog. They remain suspended in the atmosphere as clouds or fog and are supported by rising air currents and winds. When conditions are right, the droplets come together to form larger drops or sometimes ice crystals. Once the mass of the droplet or ice crystal can no longer be supported by air currents, precipitation occurs. Precipitation may take the form of rain, hail, sleet, or snow. Okay, let me scroll back up. So they're saying precipitation, rain, hail, sleet, or snow. All right, because I just said rain and snow, but they were right. Okay. Snow falling high in the mountains or in the polar regions of Earth may stay frozen there for years. Gradually, as layers of snow accumulate, the bottom layers of snow turn to ice, forming glaciers. Sometimes the snow or ice at the surface of Earth can change directly back into water vapor. This process is called sublimation. Other precipitation lands on the surface of the Earth and flows along the surface as runoff. The ground runoff gathers in streams, lakes, and oceans, and the cycle then repeats itself. Approximately 1.7% of the water on Earth is stored in the polar ice caps, glaciers, and permanent snow. However, some of the precipitation seeps into the Earth to form groundwater. This process is called infiltration. Sometimes the rock under the surface is very permeable, that is, water flows easily through it. In this case, some of the groundwater may seep to the surface, forming individual springs. Aquifers are large accumulations of underground water. They can provide an excellent source of water from wells. Groundwater flow, although measurable, is much slower than the flow in streams and rivers. That is because the passageways through the pore spaces in the materials beneath the Earth's surface are very small. Nonetheless, regarded of its speed, groundwater eventually also returns to the rivers, lakes, and oceans, and the water cycle continues. Plants and animals also play a very important role in the water cycle. Water enters living organisms by osmosis. However, through cellular respiration, water is released back into the atmosphere. As you saw in this activity, plants, especially broadleaf trees and shrubs, play a major role in the water cycle through the process of transpiration. Transpiration is the loss of water through the leaves of a plant. The human impact on the water cycle. Let me scroll down so we can see what we're talking about here. The human impact on the water cycle. The Earth's water supply remains constant, but humans can interfere with the water cycle. As population increases, living standards rise, and the industry and economy grow, humans place a greater demand on the supply of fresh water. The amount of fresh water needed increases dramatically, yet the supply of fresh water remains the same. As more water is withdrawn from rivers, lakes, and aquifers, local resources and future water supplies are threatened. A larger population and more industry also mean that more wastewater is discharged. Domestic, agricultural, and industrial wastes include the use of pesticides, herbicides, and fertilizers. They can overload water supplies with hazardous chemicals and bacteria. Poor irrigation practices raise soil salinity and evaporation rates. Urbanization of forested areas results in increased drainage of an area as road drains, sewer systems, and paved land replace natural drainage patterns. All these factors put increased pressure on the water equation. Pollutants that are discharged into the air can also affect the water cycle. Sulfur and nitrous oxides from the burning of fossil fuels, combustion in automobiles, and processing of nitrogen fertilizers enter the atmosphere. They combine with water droplets in the air to form acids. They then return to the surface of the Earth through the water cycle as acid precipitation, which is also called acid rain. And then if you scroll up, there is there's a caption I wanted to read. So here's the image, here's the caption. A person can probably exist on about 4 liters, which is about 1 gallon of water a day, for drinking, cooking, and washing. At present in the United States, people use almost 6,000 liters a day for their needs and comforts. These include recreation, cooling, food production, and industrial supply. Okay, so that's it for section 7. All right.